Hello everyone, welcome to this tutorial. In this tutorial, I will show you how to use the Sentinel 5P TROPOMI tropospheric nitrogen dioxide data in order to do a comparison of nitrogen dioxide emissions over a particular region that you are interested in, and to do a comparison basically to see the impact of the recent outbreak and to see how much drastically the emissions and in general the pollution has reduced over industrialized regions of the world. Now for this example, I'm using China as one of the examples. So over here you can see that I'm doing a comparison of 30th November 2019 and 16th of March 2020, and over here you can see that how much of a drastic reduction of the nitrogen dioxide emissions has occurred during this period due to the recent outbreak using the Sentinel 5P TROPOMI satellite datasets. So let's go ahead and get started. Alright, so the data that we will be going to download is this Sentinel 5P TROPOMI tropospheric nitrogen dioxide data. So to provide you a bit of a context, the Sentinel 5P satellite is actually equipped with the sole payload, which is also known as the tropospheric monitoring instruments. That's what TROPOMI actually stands for. So this instrument provides measurements back to the Earth, measurements of things like ozone, nitrogen dioxide, sulfur dioxide, methane, carbon monoxide, formaldehyde, aerosols, and also the cloud at high spatial and temporal resolution. So if you just scroll down a bit, you can see some information about the product itself. So the format will be actually NetCDF, and the spatial coverage, it's basically covering the whole globe. And the mission started on 2019 August 6th of August. And it's presently ongoing, so we can even acquire quite latest data as well. And you can see the spatial and the temporal resolution. So spatial resolution is 5.5 km by 3.5 km, and temporal resolution is 101.5 minutes. So that's actually considerably quite high resolution. So this is the portal that we will be using in order to download the data. Now you can either download data directly from here, or you can just go to this Earth data search, and that will redirect you to the Earth data portal, which is actually quite user friendly in terms of specifying the areas for which you would need the data. So now you can see the same satellite product is over here, the TROPOMI tropospheric nitrogen dioxide. So what I'm going to do is I'm just going to click over here, and then we can just minimize this, and now you can see the path of the satellite for which the data is available. So when you just hover your mouse over it, you can see different types of sets of data which you can download. Now my interest is actually over China. I'm interested to know about the nitrogen dioxide emissions measurements over China before and after the outbreak. So let me go ahead and click on this rectangle tool, and what I can do is I can just specify the rectangle covering like this. Now if you expand this over here, you will see that we get the response corresponding to the data which actually falls inside the rectangle which was drawn by us. Now if I were to download all of these parts, actually I can get a full coverage of the whole country, but just for the demonstration purposes of this tutorial, I'm just going to stick to only this path, which is actually given to us by one NetCDF file. Now if you want to have the full coverage of the whole country, you might have to download this part plus this path as well. Let's only focus about the eastern part of China. So in order to do that, you can just click on here, and you can also apply a filter. I would like to pick a date where the chaos was actually not that much significant, and the industrial activities in China was actually functioning quite normal. So we can get an accurate representation of how the nitrogen dioxide emissions happened actually before the occurrence of this incident. So I'll just go ahead and select one date, maybe in November, 30th of November. And the time I'm going to specify, the starting time is let's say 5 AM, because this time is actually given in UTC, which corresponds to about 1 PM in China. Like, just going to give a range, let's say from 5 AM to the same date over here, and over here it's 7 AM. So that's basically about 1 to 3 PM in China on the 30th of November 2019. And then you can just go ahead and click apply, and that'll narrow down your search by quite a lot. So now when you just hover your mouse over this, you can see that this file is actually corresponding to this path, and this file is corresponding to this path. So out of these two, I'm just going to download this first file. So what you can do is you can just click over here, download single granule data. Now, one more thing to keep in mind is that if you want to download things from this Earth data, you actually have to have a profile created first. Creating a profile is quite self-explanatory. You can just log in, enter your username and password, and enter your email, and then it'll actually provide you with a username and the password. So let me just go ahead and enter my username and password. Alright, after that it'll give you this prompt to download. So I'm just going to save this file to the folder which I'm going to work in. And similarly, I can also select a date which is actually quite close to today. So let me just go ahead and clear this up. And as the second file for the comparison, now this is in 2019 November. Now we would like to compare the emissions of nitrogen dioxide compared to before the incident, when the whole world basically was fully functioning before the outbreak. And I want to compare that with the figures which are quite recent. Let's say about 2020 March 16th. And this one I'm just going to make the change as well, and let's apply this. Now you can see that we have the corresponding NetCDF file for 2020 March 16th. Alright, let's go ahead and download this one as well, and I'm going to save that as well. After you do the download, this is how the two files will look like. You can see the extension of the files, it's .nc, NetCDF files. And it's actually providing, even the file name itself is providing you so much. The starting figure is 2023 16 4 15 55. So it's actually basically referring to the date. Yeah, so for the comparison, I'm going to use these two files. One is 2019, 30th of November 2019, and the other one is 16th of March 2020. Alright, so let's go ahead and open our IDE. For this, I'm using Spyder. And before we proceed, I would also actually like to remind you that I have done quite an extensive tutorial series of handling NetCDF files using Python. Now I'll put the link down in the description below if you would like to know how to import NetCDF files and how to explore the variables inside those NetCDF files and how to display those data into a map. These kind of exercises I have actually discussed in quite detailed manner in all of these tutorials in this tutorial series. So I'll just put the link down in the description below. So if you feel that for certain lines my explanation is actually not quite clear for you guys, I highly recommend you to actually visit those tutorials and then get yourself familiarized with those concepts before. Alright, so let's go ahead and first import the libraries that we would require in order to carry out this exercise. So first I will go to my file explorer. Now you can see that I'm already in the folder which I would like to work in. So I'm just going to right click over here and I'm going to create a new Python script. This one I'm going to name it as NO2 emissions. Alright, so I'm going to use 4 Python libraries. The first one is the NetCDF4 library, second one is the NumPy library, and third one is basically a toolkit, the basemap toolkit, and finally I'm also going to use the matplotlib library for the purposes of plotting. Alright, let's go ahead and import these libraries. Import dataset, import numpy as np, and finally import mat as plt. Alright, now just let's save this and then let's run this just to make sure that we don't have any issues with importing these libraries. Now you can see that the script ran without any issue. Again, if you would like to know how to install these libraries, you can again refer back to those corresponding tutorials, for which I'll actually put the link also down in the description below. Alright, so the first thing that I'm going to do is I'm going to import the NetCDF data. So for that I'm going to create a variable. Maybe I can say that ncd file that's equal to dataset, And over here you can provide the name of the dataset. Now if I go to the File Explorer, you can see that it's actually quite a long file name, right? So first I'm going to import this. Now since my script and the file is in the same directory, in the same location, I can just specify the file name like this. Just going to copy this and paste it over here. But if you're keeping your script and your NetCDF files in different locations, you actually have to provide the full path. And we specify that we are just going to open this in reading mode. Alright, now let's go ahead and run this and see whether we get any errors or not. No, everything is fine. Alright, now we can actually explore the file, the components of the file a bit by just typing NCD file. And you can see some details about these files. So before doing anything, let's first have a look at the different variables which are sort of embedded in this file. So what we can do is we can just say NCD data. That's the name of our main variable over here which we are creating. And you can see that there's one item called product. So I'm just going to say product dot variables dot keys. Sorry, this one should be NCD file, which is basically this file. Now what this does is this actually is going to provide us a quick overlook of all the variables which are embedded in this NetCDF files. Now you can see that we have things like time, latitude, longitude, time UTC, nitrogen dioxide, tropospheric column. So this kind of data is actually embedded in this NetCDF file. So out of this, I'm just only interested in three items. First one is the latitude, the second one is the longitude, and the third one is basically this nitrogen dioxide tropospheric column. So this is basically the variable in which they have stored all the nitrogen dioxide emission data. So we can actually extract the information corresponding to just the variables that you would need. You don't actually have to import everything. So I'm just create another variable called latitude, lat, and I'm going to store those information in this latitude variable. So that's going to be NCD file groups product, similar to what we did before, variables. And now we actually, since we know the exact name of the variable, we can just specify what is the variable which we need. So in this case, latitude, I can just say that I need the information for the latitude. Data. Now, if I just quickly show you how this one looks, you can see that the long name of this one is pixel center latitude, and the units are in degrees north, and the standard name is latitude. The data coverage is basically from minus 90 degrees to plus 90 degrees. So all this information is actually over here. And also you can see the current shape is 1,4107. So these three items are basically referring to these three items over here. So this time, scan line, and ground pixel is actually given by this value and this value. So if I want to select all the data at once, what I can do is I can just specify that I need, you can see that we actually have only one entry, only one step for the time. So I can say that I need the 0th index, which actually corresponds to this single time step that we have over here. And all the rest of the data, I'm just going to import it like this using a colon, which actually specifies all the data that's corresponding to these other elements. So I can just run this one and see if everything is okay. And now even if I come to the variables explorer, you can see that now we have one variable which is a masked array. And if I open this one, you can see that this is actually the collection of different latitude values actually. Alright, similarly, I'm also going to import the longitude data as well. And this is going to be the same, and over here, it's going to be longitude, the same variable name over here. And finally, I'm also going to import NO2 data. That's my variable name, and it can again have the same structure of the line, but just the name of the variable is, it's supposed to be this name, nitrogen dioxide. Sorry, it's this one, nitrogen dioxide tropospheric column. Now before moving on to the next step, and let me go ahead and comment this out as well. Data to lat, long, and NO2 data variables. Alright. So before going to the next step, I would also like to have a quick look at this NO2 data variable. So let's run this and let's see what happens when we type now NO2 data. You can see that it's actually a masked array. Now, if you would like to actually get the general information about this NO2 data, what you can do is, without selecting these elements of the shape, you can just type this part, and that's actually going to give you the information about the nitrogen dioxide data. Now you can see that it's actually quite detailed. First it says actually what sort of data it is, and then you can see the units. The units are actually in moles per square meter. So it's basically a mole count per each square meter, and the standard name is troposphere mole content of nitrogen dioxide, and the coordinates are actually in latitude and longitude. So you can also see something important over here. The fill value is this particular value. So for the cases where they could not actually acquire the data, or basically for the missing values, they actually replace that value with this very high value. So this is something to just keep in mind. I'm actually going to change the unit from moles per square meter to micromoles per square meter. That means we are multiplying the whole array by 10 to the power 6. I'm going to make a quick note about this fill value. So just going to say extracting the fill value. Now if you want to extract a particular item from this, what you can do is you can actually type this same script, but then you also have to follow it with the item over here. So for example, if you want to extract without actually copying and pasting, if you want to directly extract from the variable itself, let's say the long name, if you say long name over here, it'll actually say that the long name is tropospheric vertical column of nitrogen dioxide. Now instead of that, if you want to know the units, you can say that units, and that's in mole per square meter. So similarly, if you want to know the fill value that they use when NASA is actually producing these NetCDF files, if you want to know what is the fill value that they're using, you can use this, and that'll give you the fill value that they're using. So I'm just going to extract this fill value instead of copying and pasting it over here. Actually, you can do that as well, but it's quite safe to do it in this way. Fill value is basically this script. Alright, now as you remember, this fill value is, again, this whole thing is actually in moles per square meter. Now if I want to convert everything into micromoles per square meter, I have to multiply this value by 10 to the power 6. Well, and that's going to be equal to this value multiplied by 10 to the power 6, right? 1, 2, 3, 4, 5, 6. Alright. Now let's run this one and see. In the variable explorer, now we have this fill val, which is this value. Alright. Now I'm going to actually do a quick replacement of this fill value. Right, now I would like to put all of this nitrogen dioxide emission data into a NumPy array. Now let's do that by creating another variable called let's say NO2 EM, NO2 emissions. That's going to be np.array, and since we have the NO2 data over here, and again, since we are now trying to transfer everything from moles per square meter to micromoles per square meter, I'm just going to multiply this one as well by 10 to the power 6. Alright, now you can run this, and if you would like to see how this one looks, you can see that it's actually an array. So now this is how all these values look. So you can see all the missing data is actually now represented by this very big number, but then when you come to the actual emissions of nitrogen dioxide, you can see that actually these numbers are quite readable, like 4.3 micromoles per square meter, these kind of numbers. So that's actually the reason why we decided to multiply everything by 10 to the power 6. Alright, now the other thing that I'm going to do is I'm just going to actually replace all of these large numbers which are actually represented by the fill value by NaN. This number doesn't actually mean anything, it's just the fill value that they're using just to point out the locations for which we actually don't have the data. Alright, so that one you can do simply by again specifying the same NumPy array, and then you can say that if the elements of this NumPy arrays is actually equal to this, you can replace this by np.nan. Right, actually np.nan, it's basically returning an nan string for you, that's it. Right, now if I run this, yeah, this one needs to be equals equals. Now if I run this, and if I go to the variables explorer, now you can see all of those missing values are actually have been replaced by nan string. But now I'm just going to, since I actually started off with specifying all the nitrogen dioxide emission data using this particular notation, I'm just going to transfer this again into the same name, basically this NO2 EM. I'm just going to make it equal to the new NO2 data. Now if I run this and if I check the NO2 data, now you can see that these two are actually equal. So this I can put the comment as replacing the fill values by NaN. Alright, or I would say missing values by NaN. Alright, now we are going to the part of creating the base map for us. Now we can create the base map. Basically we can type something like a variable such as m. Let me go ahead and put this up, and that's going to be equal to base map, which is the toolkit that we imported over here. That's the same thing, base map. And now I'm going to specify a few parameters for the base map. So the projection, so the parameters that we would need to specify is, let's say we need the projection, we also need the resolution, and let's say we might need the lower left corner of the latitude, and we also need the upper right corner of the latitude, because over here what we are trying to do is we are just trying to capture the map canvas that we need in order to plot our data. So the other thing that we need is actually the lower left corner of the longitude values, and finally we also need the upper right corner of the longitude values. Alright, now we have to go ahead and specify these parameters. Now the projection, I'm going to use a cylindrical projection, and the resolution I'm just going to specify as L, and the lower left corner and the upper right corner, longitude and latitude values, I'm just trying to cover the full canvas. Now if you go back to the dataset over here, you can see that the coverage is actually basically the whole globe, so we can specify these values over here. So my lower left corner of the latitude is going to be -90. Yeah, this one should be upper right corner of the latitude, and the upper right corner is supposed to be 90, +90, and the lower left corner of the longitude is going to be -180, and the upper right is going to be +180. Alright. Now we can also specify that we also need to, let's say, draw the coastlines. Now you can do that by simply specifying m.draw coastlines. You can also specify a line width. Let's say I'm just going to keep it at 1.5. Now these values you can actually just play around once you run the script. If you think that the width is actually not enough for you, you can just keep on increasing or decreasing according to your test. Now let's run this one and see how it looks. Yeah, over here it should be projection. Alright, now let's run this one and see how it looks. Okay, you can see that even it gave us some sort of a plot. Basically it's covering the whole globe, so I think this information is just good enough for the time being. Alright, we can add a few more things to this base map. Now to me I feel like the line width is a bit too high, so I'm just going to reduce it to be 1. And apart from that, I'm also going to, let's say, m.draw countries. Line width is equal to 1. And now if I run this script, you will see that we will also be able to see the different countries as well. Okay, now I'm going to specify the color maps. I'm just going to name it as CMap, and that's going to be equal to plt.cm.get, and the color map that I'm going to use is actually jet. And I'm also going to add this line set under W. Now, alright, now I would like to draw the pseudo color mesh. So in order to do that, you can just say m.p color mesh over here, and the arguments that I'm going to specify are longitude, latitude, and the main set of data that we provide here is NO2 data. We can also add an argument called lat.lon, which is equal to true. And I'm also going to specify vmin and vmax, which is basically corresponding to the scaling. Vmax, vmin, vmax. So the minimum v value, the minimum value, I'm just going to set it as 0, and the maximum value that I'm going to set it as, let's say, around 500. And finally, I'm just going to link the color map that we created, the CMap, is equal to CMap. So this CMap is actually corresponding to this CMap over here. And I'm also going to create another variable called color bar. That's actually going to be equal to m.color bar. No arguments needed. And we can also set the label over here. Now, the label of the axis, we can say something like color bar dot. And now I just want to specify the unit which we use in order to specify our nitrogen dioxide emission values. Now in this case, my emission value is actually given by micromoles per square meter. Now you have to specify that as a string. So this So that's how I'm going to do that, micromoles per square meter. And I'm also going to add this line plt dot auto scale. Alright, now I would like to add a title. Let's say the title plt dot title. So the title I'm just going to add, since over here, since I'm referring to the 30th of November 2019, let me specify that over here. Nitrogen dioxide emissions over China on 30th November 2019. I think something like that should be alright. And now you can just add a that's going to be equal to plt.gcf. And finally, in order to display this, you can add plt.show. Right, now let's run this one and see what we can get. Alright, now you can see actually you can sort of get an idea about the coverage of the data. And since this is not much clear as much as I would like it to be, I'm actually going to do the setting in order to display this map as a separate window. So you can do that by just going to preferences and IPython console, and over here in graphics you can just make sure to have this in automatic, so that actually these maps will not get displayed in the console, but it'll be displayed as a separate window. But once you do that, you actually have to make sure that you restart Spyder. So I'm just going to close this one and restart. Alright, once you restart Spyder, and now if you run the same script again, now you can see that we actually can get an image. Now you can see that in this window we can just sort of just pan around and see what sort of data are actually available, and even if you want to zoom in, you can even zoom in. Now you can see that it's actually quite clear how the nitrogen dioxide distribution, the emission distribution over China over here is. You can see that over here in this region it's actually quite high. It's almost going to about 500 over here, but then the rest of the places are actually quite low. So this map is corresponding to the nitrogen dioxide emissions over China on 30th November. Now what you also can do is, since we actually do not need the bounds of our map to be actually covering the whole world, we can just set the zooming values just to capture the parts of China instead of actually having the whole world over here. So what you can do is you can just make sure that when you move your cursor around over here, you can see that the xn values at the bottom left corner, it changes. So we can actually specify a bounding box based on these xn value figures. So if I just maybe zoom in to China over here, you can see that my x and y bounding boxes can be something like, over here it can be about 87 and y value should be around 10, and over here we can actually set the bounding box to be about 144 and y value to be about 50. So in this way you can actually get a zoomed in image directly, rather than zooming it every time that you need to do a comparison. Especially when you're doing a comparison, you would actually like to have this figure zoomed in already. So you can simply do that without any issue. Axis equals to GCA and axis dot set. So what this xlim is basically your x limit, and let me set the x limit to have range from 80 up to, let's say, about 135. And similarly you can do the same thing for the y limit as well, and that's going to be x set ylim. And let's make it vary from, let's say, about 15 to 50, just like what we saw over there. And you can also save this figure as a JPEG. So we can say that fig dot save fig. Maybe I can say that NO2 2019 11:30 .jpg. Alright, now I can save this and then go ahead and run the script. And now you can see that the figure that we get over here is basically a zoomed in image by default based on the settings that we did over here. And even if you navigate back to the place where you keep your files, you can see one JPEG over here, which you also can actually just use to zoom in and see what sort of data are over here. So you can see actually this area of China is emitting quite a lot of nitrogen dioxide during this particular day, which is almost equal to about like 500 micromoles per square meter. All right, now that's 2019, before all the chaos happened, isn't it? Now let's go over here and change this file name to be this, which is the 2020 March 16, which is a quite recent date in comparison to the date which I'm actually creating this video. And the things that would change is the rest will actually remain same. Just over this one needs to be changed to 16th March 2020. Alright, now let's save this and we can run the script again, and we can wait until the script runs. Nitrogen dioxide emission over China on 16th of March. So if you remember the previous figure, you can see that it's actually quite a big difference right now. Now I'll open first the 2019 figure. Let me zoom in this a bit. And now when I go from 2019 to 2016, you can see that what kind of a change has actually occurred. Maybe I can compare these two figures side by side. So you can see that due to the outbreak that happened, you can see that the industrial activities in China has drastically reduced and the pollution has drastically reduced. Now as a result of that, the nitrogen dioxide emissions over China during the last couple of months, the last 3 to 4 months, has also drastically come down now. Now you can see a very clear reduction in the emissions over here now. Now a majority of this region where it used to be around 500 micromoles per square meter is now only about this range, about 200 to 300, apart from these very localized spots. So I guess that's about it for the tutorial. I guess you learned something new. Again, if you find certain lines of this code to be a bit confusing, I would actually recommend you to go back to follow my handling NetCDF files using Python tutorial series, and each and every line was actually was explained very well in that tutorial series. So I hope you learned something new. So thanks a lot for watching, guys, and if you like this tutorial, show your support by hitting the like button, and if you really like this tutorial, you can even consider subscribing. So I'll see you in the next one.